friends, welcome to the channel with another video related to aviation. So in this video, with the help of Microsoft Flight Simulator, I will give you a brief idea about major aircraft components and how the aircraft is controlled. In the earlier video, I explained about how airplanes fly and the aerodynamic forces acting on the airplane. Please do watch that video before watching this because it will help you to better understand this video. Here is the link. Although airplanes are designed for a variety of purposes, most of them have the same major components. Most airplane structure includes the fuselage, wings, an empennage, landing gear, and the power plant. The fuselage is the main structure or the body of the aircraft. It provides space for passengers, cargo, controls, and other equipment. In single-engine aircraft, it also houses the power plant. The wings are aerofoils attached to each side of the fuselage and are the main lifting surfaces that support the airplane in flight. How the wing produces lift is explained in another video. Attached to the rear or trailing edge of the wings are two types of control surfaces referred to as the ailerons and flaps. Ailerons extend from about the midpoint of each wing outward towards the tip and move in opposite direction to create aerodynamic forces that cause the airplane to roll. Flap extend outward from the fuselage to near the midpoint of each wing. The flaps are normally flush with the wing surface during cruise flight. When extended, the flaps move simultaneously downward to increase the lifting force of the wing for takeoff and landings. The correct name for the tail section of an airplane is empennage. The empennage includes the entire tail group, consists of a fixed surfaces such as the vertical stabilizer and the horizontal stabilizer. The movable surfaces include the rudder, elevator, and the trim tabs. Landing gear is the principal support of the airplane when parked, taxiing, takeoff, or when landing. In this aircraft, the landing gear consists of three wheels, two main wheels, and a nose wheel. The primary function of an engine is to provide the power to turn the propeller. The propeller translates the rotating force of the engine into a forward acting force called the thrust that helps move the airplane through the air. To understand how the aircraft is controlled, first we have to understand about the three axes of rotation. Whenever an airplane changes its flight attitude or position in flight, it rotates about one or more of the three axes, which are imaginary lines that passes through the airplane's center of gravity. The axis of an airplane can be considered as an imaginary axle around which the airplane turns, much like the axle around which a wheel rotates. At the point where all three axes intersect, each is at 90-degree angle to the other two. The axis which extends lengthwise through the fuselage from the nose to the tail is the longitudinal axis. The axis which extends crosswise from wingtip to wingtip is the lateral axis. The axis which passes through the center from top to bottom is called the vertical axis. The airplane motion about its longitudinal axis resembles the roll of a ship from side to side. In fact, the names used in describing the motion about an airplane's three axes were originally nautical terms. They have been adapted to aeronautical terminology because of the similarity of motion between an airplane and the ship. Thus, the motion about the airplane's longitudinal axis is called roll. Motion about its lateral axis is referred to as a pitch. Finally, an airplane moves about its vertical axis in a motion which is termed yaw, that is a horizontal movement of the airplane's nose. The three motion of airplanes, roll, pitch, and yaw, are controlled by three control surfaces. Roll is controlled by the ailerons, pitch is controlled by the elevators, and the yaw is controlled by the rudder. Aircraft flight control systems are classified as primary and secondary. The primary control includes the aileron, elevator, and rudder. Secondary control system improves the performance characteristics of an airplane or to relieve the pilot of excessive control forces. Example of secondary control systems are wing flaps and trim systems. Now let's get inside the cockpit of a Cessna 152 aircraft and let's look at the basic controls. Like a steering wheel in a car, the aircraft has a control wheel or a control column or a yoke, and some aircraft have joystick. It can be moved in right or left and also backward and forward. These are the rudder pedals for moving the rudder and also for brakes. Moving the control wheel to the right causes the right aileron to deflect upward and the left aileron to deflect downward. The upward deflection of the right aileron decreases the camber, resulting in decreased lift on the right wing. The corresponding downward deflection of the left aileron increases the camber, resulting in increased lift on the left wing. Thus, the increased lift on the left wing and the decreased lift on the right wing causes the airplane to roll to the right. And when the control wheel is moved left, it causes the left aileron to deflect upward and right aileron to deflect downward, which increases the lift on right wing and aircraft rolls to the left. Aft movement of the control column deflects the trailing edge of the elevator surface up. This is usually referred to as a up elevator. The up elevator position decreases the camber of the elevator and creates a downward aerodynamic force, which causes the tail of the airplane to move down and the nose to pitch up. Moving the control column forward has the opposite effect. In this case, the elevator camber increases, creating more lift on the horizontal stabilizer. This moves the tail upward and pitches the nose down. During a turn, a raised wing produces more lift, but it also produces more drag. This added drag attempts to yaw the airplane's nose in the direction of raised wing. This is called adverse yaw. The rudder is used to counteract the adverse yaw. Moving the left or right rudder pedal controls the rudder. When the rudder is reflected into the airflow, a horizontal force is exerted in the opposite direction. By pushing the left pedal, the rudder moves left. This alters the airflow around the vertical stabilizer and creates a sideward lift that moves the tail to the right and yaws the nose of the airplane to the left. Rudder keeps the airplane nose pointed in the direction of turn, not to turn the airplane. Remember, the airplane turns by banking. All turns are coordinated by use of ailerons, rudder and elevator. Applying aileron pressure is necessary to place the airplane in the desired angle of bank, while simultaneously applying rudder pressure to counteract the resultant adverse yaw. During a turn, the angle of attack must be increased by applying the elevator pressure because more lift is required when in straight and level flight. Now let's talk about secondary flight control. Flaps are the most common high lift devices used on practically all airplanes. The flaps are normally flush with the wing surface during cruising flight. When extended, the flaps move simultaneously downward to increase the lifting forces of the wing for takeoffs and landings. On some airplanes, high drag devices called spoilers are deployed from the wings to spoil the smooth airflow, reducing lift and increasing drag during landing. They are also called speed brakes. Trim systems usually consist of cockpit control and small hinge devices attached to the trailing edge of one or more of the flight control surfaces. They are designed to help minimize a pilot's workload by aerodynamically assisting movement and position of the flight control system to which they are attached. I hope you all got the basic idea on how aircraft fly. If you liked it, then please don't forget to share this video and subscribe to my channel. Thank you so much for watching this video. Good day.